Hi there, John here again. Now, in the previous two videos, I showed how some basic examples of closed and open pocket geometries are defined in iMachining. Now, for this last part, I'll define several examples of semi-open pocket geometries. And like I've done previously, I'll also show you the toolpath techniques that iMachining uses on those geometries. So I'll start off with my first semi-open pocket geometry, and then I'll continue until we're finished with the last example. Okay, so my CAM part is on the screen and ready to go. I'll pan over and zoom in to the first example, which is just a basic semi-open pocket with just a single open edge. I'll go to the SolidCAM Manager to add an iMachining operation. I'll right-click Operations, Add Milling Operation, and select 2D iMachining. The iMachining operation dialog box is displayed, and I'll click the New button to start the geometry definition. Now for this operation, the geometry is defined as a single open edge, semi-open pocket. Now as you can see, there is only one chain to select for this example. I'll pick on the lower contour of the pocket, use Auto Constant Z to close the chain, and then I'll click Yes to accept the chain selection. Now the next thing I have to do is right-click Chain 1 in the chain list, like I've been doing in the previous examples. Only this time, I have to choose the option of Mark Open Edges. With this option, the Mark Open Edges dialog box appears, and I can define parts of the chain as open or closed. I can even toggle between the two different selection types. I can also select a single entity at a time, or I can choose the From Two Entities option to simplify my selection. For this example, I'll use the default Mark As option of Open, and I'll switch the select method to From Two Entities. Keeping the path of the chain direction in mind, I'll pick on the first entity in the chain and then the last entity. All entities on the same Z level will be connected from the first selection to the last. In the SolidWorks graphics area, you'll see that the color of the open edge changes to black. The iMachining technology is informed that the tool can now enter from this open edge. At this point, the open edge geometry is defined, and I can click OK to accept the selection, and then I'll click OK again to confirm the geometry definition. Next, I have to define my tool and milling levels for the operation. Now if you're just joining in, all the pockets in this example use the same tool and have the same exact depths. So I'll make those definitions now in the first semi-open pocket example, and then I'll just use the Save and Copy function to copy them to a new operation for the next example. Moving down to the Tool page, I'll choose my tool from the Part Tool table. Now to finish up the operation definition, I'll switch to the Levels page to define the milling levels. First, I'll define the upper level, which is again the top face of my stock model. Then I'll define the pocket depth, which is the bottom edge of this semi-open pocket. Now, in continuing to keep things organized, I'll name this iMachining operation Semi-Open Pocket. And I can now click Save and Calculate to add the operation to the CAM tree and finally calculate the toolpath. Then I'll click Simulate to open up the simulation control panel. Using the Host CAD mode, I'll click the Play button. You'll see that the tool enters from the open edge and the toolpath continues. Now, I want to exit the simulation control panel and simply just click the Save and Copy button. As I said before, all the definitions from the previous operation are copied over. The only thing I have to do now is make a new geometry selection. So, I'll click the New button on the geometry page to do that. I'll first pan over to the next example. Now for this operation, the geometry should be defined as a single open edge, semi-open pocket with island. The first chain to select is the pocket contour, followed by the chain on island contour. So in the SolidWorks graphics area, I'll pick on the lower contour of the pocket, select Auto Constant Z to close the chain, and then I'll click Yes to accept the chain selection. And I'll select the chain on island contour in a similar fashion. Now in the chain list, I'll right-click Chain 1 and choose Mark Open Edges to once again display the Mark Open Edges dialog box. I'll then mark the following edges as open. Now I'll click OK to accept, and then I'll click OK again to confirm the geometry definition. Now I can name this operation Semi-Open Pocket Island. I'll then click Save and Calculate to add this iMachining operation to the CAM tree and calculate the toolpath. And once again, I'll click Simulate. Now when I click Play, the tool enters just as it did before. When the island is reached, it is separated from the remaining material first, and then the toolpath continues. Now I'll exit the Simulation Control Panel, and then click Save and Copy to start a new operation with the same settings. When the copied operation opens, I'll click the New button to start the new geometry definition. First, I'll bring the next example into view. And then I'll perform the chain picking. Now for this operation, the geometry is defined as a single open edge, semi-open pocket with multiple islands. So here again, I'll select the first chain, which is the outer chain on pocket contour. I'll then select the two chains on island contours. So now what's next? Again, I have to mark the open edges of the pocket. And to do that, I'll right-click Chain 1 in the chain list and choose Mark Open Edges. I'll use the From To Entities option again, and in the SolidWorks graphics area, I'll pick on the appropriate edges. I can now click OK to accept, and then OK again to confirm the geometry definition. I want to name this operation Semi-Open Pocket Islands. I'll click Save and Calculate, and then I'll click Simulate. When the Simulation Control Panel appears, I'll play the simulation. Just like it did previously, the tool enters into the pocket through the open edge. The two islands are separated, and the remaining areas of the pocket are cleared. Now moving on to the last three examples, we'll take a look at semi-open pockets with multiple open edges. First, I have to, of course, exit the Simulation Control Panel, and then click the Save and Copy button to create a copy of the current operation. Then, I'll define the geometry by clicking the New button. Now, I'll zoom in to the next example. And for this operation, the geometry is defined as a multiple open edge, semi-open pocket. In the SolidWorks graphics area, I'll pick on the lower contour of the pocket and then use the option of Auto Constant Z to close the chain. When prompted, I'll click Yes to accept the chain selection. Now, just as I did before, I simply have to mark the appropriate edges as open. I'll again go to the chain list to do that, where I can right-click Chain 1 and choose Mark Open Edges. When the dialog box appears, I'll choose the From To Entities option in the Select section. At one open edge, I'll pick on the first entity and then the last entity. Then at the other open edge, I'll do the same. Now, I can click OK to accept, and then OK again to confirm the geometry definition. This operation I'll name Semi-Open Pocket 2 Edges. I'll click Save and Calculate, and then I'll click Simulate to open up the Simulation Control Panel. After clicking the Play button, you'll see that the tool enters from one open edge and then breaks through to the other side. I'll now exit the Simulation Control Panel and click Save and Copy to open a new operation with the same settings. To start the new geometry definition, I'll of course click the New button. First, let me just move over to the next example. For this operation, I'll define the geometry as a multiple open edge, semi-open pocket with island. Now the first chain I have to select is the pocket contour, and the second chain is the island contour. I'll pick on my initial edge in the SolidWorks graphics area. Using Auto Constant Z, I'll close the chain, and then I'll click Yes to accept the chain selection. I'll select the chain on island contour in the same way. Now I have to mark the open edges. So I'll right-click Chain 1 in the Chain List section, and then choose Mark Open Edges. For Mark As, I'll leave the default option of Open, and I'll switch my select method to From To Entities. In the SolidWorks graphics area, I'll mark the open edges on the one side of the pocket, and then I'll mark the open edges on the other side of the pocket. Clicking OK will exit the Mark Open Edges dialog box, where I can click OK again to complete the geometry definition. Now I want to name this operation Semi-Open Pocket, Two Edges, Island. I'll click Save and Calculate, and then I'll click Simulate. When I click Play, we should see the tool enter from the one side, separate the island, and then continue through the other side. I'll now exit the Simulation Control Panel and click Save and Copy to open a new operation with the same settings. To start the new geometry definition, I'll click the New button. Now I'll move over to the last example that I'd like to show you. For this operation, I want to define the geometry as a multiple open edge, semi-open pocket with multiple islands. The geometry selection process for this example is very similar to the previous one. Now the first chain to select is the pocket contour, followed by the two island contours. So in the SolidWorks graphics area, I'll make my 3 chain selections. Now of course, I have to mark my open edges. And to do that again, I'll right-click Chain 1 and choose Mark Open Edges. I'll just go with the same options as before, and then pick on my open edges. When I'm finished with my open edge selections, I'll click OK, and then I'll click OK again to complete the geometry definition. I'll name this last operation Semi-Open Pocket, Two Edges, Islands. Clicking Save and Calculate will calculate the iMachining toolpath and add the operation to the CAM tree. And finally, I'll click Simulate. Now when I click Play this time, we can watch as the tool enters, both islands are separated, and the toolpath continues. Now that's it for these semi-open pocket geometry examples. As you can see, these are again just some basic examples. However, they're intended to help show you the geometry selection process in iMachining and to also show the types of techniques that are used when cutting the different geometries. Now, I'll be including this completed CAM part for you if you'd like to take a closer look at the operations, the geometry chains, or to even simulate the iMachining toolpath firsthand. You can either download it from our website, or you can open it directly from our interactive guide. So, thanks for watching another SolidCAM Professor video series dedicated to our patented iMachining technology. You can find more great SolidCAM Professor videos on the Professor page at www.solidcam.com.